Today we're looking at ratios, and a ratio is a comparison of two quantities. It states how much of one thing there is as compared to another in the example. There are three different ways to write ratios. The first one is to write x with the word 2y. Another way to write it is x 2 dots y, and the last way is as a fraction where x is always the numerator over y. The quantities of x and y are also known as terms in ratios, and they describe the two quantities that we are comparing. So let's look at this first example. In this example, we can see that there are 2 circles, there are 3 triangles, and there are 4 squares. And altogether, there are 9 shapes. And it's important to write these down first. It will make it a lot easier to answer the rest of the questions. So the first way that we can describe this pattern is to look at different parts of the pattern and write them as ratios. So in this first example, we're wanting to write a ratio that compares the number of squares to the number of circles. So the first way I could write it is to write that there are 4 squares to 2 circles. The other way is to write it as 4, the number, the word 2, and the number 2 to describe that there are 4 squares to 2 circles. And the last way is to write it as 4 over 2. And all of these ways here is basically to describe that for every 4 squares there are 2 circles. Now another way to look at it is to compare one part of this example to the whole example, so the total number of shapes. So here it's asking to compare the number of triangles to the total number of shapes. So the number of triangles is 3, and we're going to do those 2 dots, and the total number of shapes is 9. So 3 triangles to 9 shapes altogether. The other way we can write it is 3 and the word 2 and the number 9. And lastly, we have 3 over 9. And all of these 3 different ways basically describe that for every 3 triangles there are a total of 9 shapes together. Here's another example where we've got a glass of cordial, and for every 1 part of cordial we have 4 parts of water to dilute it. So the first part of the question asks, what is the ratio of cordial to water in this drink? So we want to know cordial to water. So we can see that there's 1 part of cordial to 4 parts of water, and that's how you write the first answer. Question 2 asks, what is the ratio of water to cordial? So this time we want water, 2 little dots, to cordial. So we can see here that there are 4 parts of water to 1 part of cordial. So depending on which component you make x or y will change the order in which it is written, and it's really important to go by the order that is given in the question. Part C, what is the ratio of cordial to the total number of parts of the drink? So we want cordial to the total. So if we look here, we've got 4 parts water, 1 part cordial, so the total is 5 parts altogether. So cordial is 1 and the total parts is 5. So the ratio of cordial to the total number of parts of the drink is 1 to 5. It's now asking what fraction of the drink is cordial. So this time, instead of writing it as this, we're now going to write it as a fraction. So with fractions, we know that the first bit tells me what I'm actually looking at, and then the denominator tells me the total. So really, it's 1 over 5. This time, it's asking what percentage of the drink is water. So we know that the water is 4 parts, and cordial is 1 part, and the total is 5. So if you remember when we were doing our fractions and percentages, so we have the part of water compared to the total. And remember, if we want it to be a percentage, we're going to multiply it by 100. So there are 4 parts over 5 times 100. And if you calculate that, that should be 80%. So 80% of the drink is water. Here are some other examples, and sometimes you'll be asked to compare 2 different quantities, but they're different units. So it's really important that when we do compare them for ratios, they have to be the same units. So if I have a look here, it says to compare 7 months to 1 year. As you can see, they're 2 different units. One is months and the other is year. So what we're going to do is we're going to convert 1 year to 12 months. So now I can write the ratio of 7 to 12. And this is correct because now they are both in the units of months. If I look at the bottom example here, we've got 47 centimetres to 1 metre. Now it's better to have whole numbers compared to decimals, so what I'm going to do is I'm going to convert my metres to 100 centimetres. So my ratio is 47 centimetres to 100 centimetres. And now this is a good ratio because they are both the same units.